Okay, so get ready because we're about to dive into something kind of unexpected. We're talking about wastewater treatment, but not in the way you might usually think about it.
Yeah, it's definitely not the most glamorous topic.
Right. But that's why this is so cool. We're talking about turning something we think of as ew, gross into whoa, that's brilliant.
Yeah,
It all comes down to this revolutionary new method inspired by, get this, medical dialysis.
I know, right? Pretty wild.
Totally. And this whole deep dive is based on a Nature Water article that really caught my eye.
It's a good one. Lots to unpack.
It is. And whether you're someone who, works in an industry that deals with wastewater or you're passionate about sustainability or even if you just love a good science story, I think you're going to find this fascinating.
For sure. It's really cutting edge stuff.
So, the basic problem is that a lot of industries, I mean a lot, generate wastewater that's both salty and full of organic material.
Yeah, it's a tough combination to deal with.
And the traditional ways of cleaning it up, well, they can be expensive, not to mention energy intensive, and sometimes they even make the problem worse.
Exactly. The current methods, they often involve diluting the wastewater, which means using up a ton of fresh water, and that just makes the whole process less efficient. And then there's the whole issue of the organic material clogging up the systems, what we call fouling.
Okay, so this is where dialysis comes in, and I have to say I'm fascinated by the idea of adapting something that cleanses blood to clean up wastewater.
It's kind of a crazy idea when you think about it.
Right, like something out of science fiction. So how does that even work?
Well, imagine like a membrane separating the contaminated wastewater from clean fresh water. The salts, they naturally want to move across this membrane into the fresh water, leaving those bigger organic molecules behind.
Yeah.
And the really cool part is that this all happens without any pressure, meaning we use less energy and have fewer fouling issues.
No pressure. That's incredible. So I can definitely see how that would be a huge deal in terms of efficiency. But what's the bigger picture here? Like, why should anyone who's not, a wastewater engineer be excited about this?
Well, the implications are huge. For one thing, think about water conservation. We're removing salt without needing massive amounts of fresh water. That's a massive win for sustainability, especially in those areas where water is scarce.
Right, that makes a lot of sense. But didn't we also talk about how this method is good for more than just cleaning? Something about resource recovery.
You got it. Because we're separating the salts, it becomes much easier to treat the remaining organic material or even recover valuable chemicals from it.
So we could actually be extracting stuff like nitrogen or phosphorus that can then be used in fertilizers.
Exactly. It reduces our reliance on mined minerals and stuff like that.
Yeah.
It's a win-win, better wastewater treatment and valuable resources all in one.
So not only are we cleaning up the water, we're potentially turning what was once waste into something we can actually use.
That's awesome. Now, in the article, the researchers compared dialysis to something called ultrafiltration, which I guess also uses a membrane, but with pressure, right? What did they find?
They found that for separating salts from small organic molecules, dialysis was the clear winner.
Interesting. And I love this quote from Menachem Alimala, one of the study's authors. He said, dialysis was astonishingly effective in separating the salts from the organics in our trials.
Yeah, astonishingly effective is a great way to put it. And let's not forget about fouling. Dialysis is a lot more resistant to it because it's not using pressure, which means less cleaning, lower costs, and longer-lasting membranes.
So, reduced freshwater use, lower energy, minimal fouling, resource recovery. This is starting to sound like the ultimate solution for wastewater treatment. But is it really a cure-all? Does it solve every single problem? Well, maybe not a magic bullet, but it is an amazing pre-treatment step. It's like it gets the wastewater ready for other treatments like biological processes or advanced oxidation.
I see. So those other treatment methods become more effective.
Exactly. It kind of unlocks their full potential.
So to recap, we've got reduced freshwater use, lower energy consumption, minimal fouling, resource recovery, and a boost in the effectiveness of other treatments. Honestly, this dialysis technology seems almost too good to be true.
It is a big deal, a real breakthrough, and it's only the beginning. I think this technology has the potential to really change how we approach wastewater treatment.
Speaking of potential, before we jump into part 2, I want to leave our listener with something to think about. We talked about how wastewater dialysis was inspired by medical dialysis, but what other fields or industries could benefit from borrowing ideas from areas that seem totally unrelated?
It's a great question. It really highlights the importance of being curious and looking outside of our own little bubbles for solutions. Sometimes the best ideas come from making these unexpected connections.
We'll be back soon with part 2, where we'll delve even deeper into wastewater dialysis. See you then.
Welcome back to our deep dive on wastewater dialysis. Before the break, we were talking about how this technology could really revolutionize wastewater treatment with an idea borrowed from the medical field.
It really makes you think, like, what other amazing solutions are out there just waiting for us to connect the dots between fields that seem totally different, you know?
Absolutely. But before we get too carried away, singing the praises of this technology, it's important to address a question that's probably on our listeners' mind.
Oh, okay. What's that?
Well, we've been focusing on all the positives, but let's be realistic, no technology is perfect, right? What potential downsides or challenges do you think we might run into with this method?
That's a really good point. I mean, it's easy to get excited about a shiny new toy, but it's important to look at the full picture. What comes to mind for you?
Well, one challenge could be scalability.
Mm-hmm.
Like dialysis has shown a lot of promise in the lab, but implementing it on a large industrial scale, that could be tricky.
Yeah, I imagine that's a common problem with any new tech. Moving from a controlled environment to the real world always comes with its own set of hurdles. What else?
Another thing is cost. High-quality membranes, the ones that are essential for the process, those can be expensive, which could impact the economic feasibility, especially for smaller companies that might not have those resources.
So affordability and accessibility, those are key if we want to see this tech widely adopted.
Exactly. It has to be effective, but also make sense economically and be something that lots of different industries can actually use.
Okay, that makes sense. But shifting gears a bit, I'm still really curious about the resource recovery aspect of this. We touched on it earlier, but can we dive a little deeper? I mean, it just seems like such a game changer for sustainability, for creating a circular economy, you know?
It totally is. Instead of just treating wastewater and then discarding it, we're talking about extracting valuable materials and then reusing them.
So we're recovering stuff like salts and other chemicals from the wastewater. But what can those recovered materials actually be used for?
Well, let's start with salts. Recovered salts can have all sorts of applications. Things like fertilizer production, road de-icing, even water softening, and then certain industrial processes as well.
Wow, that's way more than I would have thought. What about the other chemicals? Anything interesting we can do with those?
Well, it depends on the specific industry and the type of wastewater, but we could recover things like organic compounds, metals, or nutrients that could be used in agriculture, manufacturing, all kinds of sectors, really.
So we're not just cleaning up the water, but we're creating this closed-loop system where waste becomes a valuable resource.
Exactly. That's the heart of a circular economy, and wastewater dialysis is a big part of making that vision a reality.
This is pretty mind-blowing. Who knew that something like wastewater could have so much potential?
It really does show how innovative we can be when it comes to finding solutions to these big problems. But of course, there's still challenges to figure out.
Like what? What else might stand in the way of this becoming, the go-to solution?
Well, for one thing, we need even better, more efficient membranes. Membranes that can handle the demands of large-scale industrial applications. Right now, the technology is still in its early stages, so there's definitely room for improvement.
So making sure it performs well in those real-world settings. What else?
And then there's the economic piece, like we discussed earlier. The cost can be a barrier. So we need to find ways to make it cost-effective so that it's accessible to a wider range of industries, not just the ones with lots of resources.
Right, that balance between innovation, practicality, and affordability.
Exactly. But there is good news. There are researchers and engineers all over the world who are working hard to address these challenges, and they are making progress.
It feels like we're on the verge of something big when it comes to wastewater treatment. It's exciting to think about.
It is. The potential benefits for the environment, for the economy, for society, they're huge. This could be a real game changer.
I'm really eager to see how this all unfolds in the next few years.
Me too. It's amazing to see what we can accomplish with a bit of creativity and ingenuity, and it gives me hope that we can find solutions to even the toughest problems.
Speaking of creative solutions, can we circle back to something we talked about earlier, the importance of cross-disciplinary thinking? I mean, wastewater dialysis is such a great example of that principle in action.
Absolutely. It's a reminder that we need to look beyond our own narrow areas of expertise and be open to a broader perspective, to see connections where others might not.
Thinking outside the box, being open to new possibilities.
Exactly. Who knows what other groundbreaking discoveries are waiting for us when we start collaborating across different fields? The possibilities are endless.
It's a very exciting thought. The future of innovation depends on breaking down those barriers and taking a more holistic approach to problem solving.
I completely agree. And I think wastewater dialysis is a perfect example of what we can achieve when we dare to think differently.
We're back for the last part of our deep dive into the world of wastewater dialysis. Before we moved on, we were talking about how this technology really shows us the power of thinking outside the box and borrowing ideas from unexpected places.
It's amazing, right? I mean, who would have thought that something from medical science could have such a big impact on wastewater treatment? It really highlights how connected different areas of knowledge can be.
It really does. And it makes you wonder what other incredible solutions are out there, just waiting for someone to make those connections.
I know. There's so much potential for innovation when we're open to looking beyond our own little worlds and embracing a wider perspective.
For sure. But something's been on my mind as we've been talking about this. We spent a lot of time focusing on dialysis, but it's not the only game in town when it comes to sustainable wastewater treatment, right? I mean, how does it compare to some of the other options out there?
That's a great point. It's important to remember that dialysis isn't a magic bullet that will solve every problem. There are other promising technologies out there, each with its own pros and cons.
Right.
Like, for example, you've got constructed wetlands, which use natural processes to clean up wastewater.
Oh, yeah. Constructed wetlands, I've heard of those. They seem like a very eco-friendly approach.
They are. They're really effective at removing certain pollutants, and they have this added bonus of creating habitats for wildlife, so it's a win-win. It's a great example of working with nature instead of trying to fight against it.
I like that. So how does dialysis compare to something like that? When would you choose one over the other?
Well, dialysis really shines when you need to remove high concentrations of salts and those smaller organic molecules.
Right.
It's very precise and efficient for that specific purpose. Constructed wetlands, they're better suited for wastewater that has lower salinity and a wider range of pollutants.
So it's all about matching the right technology to the specific problem.
Exactly. It's not about one technology being better than another. It's about choosing the best tool for the job. And sometimes the most effective approach involves using multiple technologies together.
That makes sense. It's about finding the right combination. But beyond just how well the treatment works, we also need to think about the environmental impact, right?
Absolutely. We need to look at the whole picture, considering things like energy use, resources, and any potential emissions. It's about taking a holistic view of sustainability.
For sure. And how does dialysis measure up in that regard?
Well, one of the great things about dialysis is that it doesn't use high pressure or harsh chemicals, so it has a relatively low environmental footprint compared to some other methods out there.
That's good to hear.
Yeah, it's definitely a plus.
So we've talked about the science behind dialysis, the potential benefits and challenges, and how it compares to other technologies. But I think it's time to bring it back to something our listener might be wondering. What does all this mean for me? How does this affect my everyday life?
That's a great question. And the answer is that cleaner wastewater means cleaner water sources for everyone. It means less pollution in our rivers and lakes and oceans. And that's good for human health. It's good for wildlife. It's good for the whole ecosystem.
So it's about protecting our most precious resource, water.
You got it. Clean water equals a healthier planet for everyone.
Absolutely. That's something we can all agree on. But sometimes these big environmental problems can feel so overwhelming, It's easy to feel like individual actions don't make a difference.
I get that, but I truly believe that every single person can make a difference.
So what can we do? How can we as individuals support things like dialysis and other sustainable wastewater treatment technologies?
Well, first and foremost, stay informed. Learn about the challenges we're facing, understand the potential solutions, and talk to people about it. The more we raise awareness, the more momentum we create for change.
Okay, so knowledge is power, and sharing that knowledge is key. What else?
Think about the choices you make as a consumer. Support businesses that are making sustainability a priority. And never underestimate the power of your vote. Let your elected officials know that you care about these issues and that you want to see policies that promote environmental responsibility.
So we can vote with our wallets and with our voices. It's about making conscious choices that reflect what we believe in.
Exactly. And one more thing, don't be afraid to get out there and get involved. Volunteer with organizations working on water issues. Reach out to your elected officials. Be an advocate for change.
I love that. It's so encouraging to hear that we're not powerless when it comes to these big challenges, that even small actions can have a ripple effect.
That's so true. When it comes to protecting our planet, every little bit helps.
Well, this has been an amazing conversation. Thank you so much for joining us and for sharing your expertise. I feel inspired to do my part.
It's been my pleasure. And to everyone listening, we hope this deep dive has sparked your curiosity and given you some hope for the future of wastewater treatment. Thanks for joining us on the deep dive.